Find the length of the curve r equals 1 minus cosine theta for theta between 0 and 2 pi. Using the arc length formula in polar coordinate, s equals the integral from alpha to beta, the square root of r squared plus dr d theta squared d theta, where r is 1 minus cosine theta and dr d theta is the derivative of r with respect to theta. The derivative of 1 is 0 and the derivative of cosine is minus sine. Thus, dr d theta is simply sine of theta. The argument of the square root r squared plus dr d theta is now 1 minus cosine of theta squared, this is r squared, plus sine of theta squared. This is 1 minus 2 cosine of theta plus cosine squared of theta plus sine squared of theta, but sine squared plus cosine squared theta is 1. 1 plus 1 is 2. This is 2 minus 2 cosine of theta. The square root of r squared plus dr d theta squared is now the square root of 2 minus 2 cosine of theta. We won't be able to integrate this directly unless we rewrite this. 2 minus 2 cosine of theta can be rewritten as 2 times 1 minus cosine of theta, which is 2 times 2 times 1/2 of 1 minus cosine of theta, which is 4 times 1/2 1 minus cosine of theta, but we recognize that the 1/2 1 minus cosine of theta part is sine squared of theta over 2. This is from the double angle formula. Thus, the square root of 2 minus 2 cosine of theta is the square root of 4 sine squared of theta over 2, which is 2 sine of theta over 2. In the problem, the lower limit of integration is 0 and the upper limit of integration is 2 pi. The integral goes from 0 to 2 pi. Thus, this is the integral from 0 to 2 pi of 2 sine of theta over 2 d theta, but the antiderivative of sine of theta over 2 is negative cosine of theta over 2 times 2, and we evaluate it from 0 to 2 pi. Negative 4 cosine of 2 pi over 2 minus negative 4 cosine of 0 over 2. Negative 4 times cosine of pi is negative 1, plus cosine of 0 is 1. Negative 4 is positive 4. The answer is 8.